This video will be seeing the basic mathematical concept behind the formation of pin codes. Yeah, so see this question for instance. How many 5-digit codes can be formed from the digits 2, 3, 4, 5, 6, 7, 8 without repetitions such that the code is even? So now, you want to hack a pin code, and the information you have is that the code is a 5-digit code. The code is even, that is, the last digit is an even number, and then there is no repeated number in that code. All 5 digits are distinct, none of them is repeated. Then mathematics, particularly the concept of permutation, can help us know the amount of effort you put in to getting that pin code, to hacking it. When I say effort, I mean the number of trials you have to run to get the exact 5-digit code. Of course, you might be lucky, your first trial might even give you the code, but we're saying in the worst case, the maximum number of trials you would have to go through before you eventually get that code. This concept of permutation can help us with that. So the analysis of the question now is that we have this available set of numbers for the pin code. The pin code is generated from this set 2, 3, 4, 5, 6, 7, 8. These are the numbers that are contained in the code. But then it is a 5-digit code, right? And another information is that the code is even. That is, the code must end with either 2, 4, 6, or 8, because those are the even numbers in this set that were given. In our set, we have a total number of 7 digits. And for the last position, the last number in our code, we already know that it can be any of these 4 numbers, 2, 4, 6, 8. Now, the 5-digit code is even if the last digit is even. We've said that. And so if we take out the last digit from our guess, we already know our last digit is any of those 4 digits, right? 2, 4, 6, 8. If we take the last digit off, let's now move to the first digit. For our first digit, we'll be having 6 numbers left. Remember, the total number of digits we can pick from are these 7 digits. Our last digit is taking one number at a time, and so at every instance that our last digit has taken a number, we're left with 6 numbers to fill up the first position, right? And then the second position, at every instant that our first position has taken one number, the second position is left with 5 digits, because our first position has taken a number and our last position also has taken a number. And the third position, so similarly, at every instance like that, the first position has taken a number, and the second position has taken a number. So the third position will be left with 7 minus 3, because we know already our last position is constant. So 3 positions are taken already, the first, the second, and the last. So the third position is left with 4 positions and 4 choices from the 7 total choices to pick. And then finally, the fourth position, we have 3 choices left, because the first position has taken a number to leave 6 numbers. The second position has taken a number to leave 5 numbers. The third position has taken a number to leave 4 numbers to shuffle. And remember, the last position, the fifth position, is fixed already. And then, so we're left with 7 minus 4. The first, second, third, and last. Those 4 positions are taken. So for the first position, 7 minus 4, we're left with 3 numbers to shuffle on. And so we multiply each of those instances. The first position has 6 numbers to choose from. The second position has 5 numbers to choose from. The third position has 4 numbers to choose from. The fourth position has 3 numbers to choose from. And the last position has 4 numbers to choose from, right? Because there's no repetition. That's why whenever we pick one position is gone, we subtract it from the total number of choices that we can pick a digit from to shuffle. And so when we do this multiplication, we have 1,440 ways of running that shuffle. In essence, if you have all this information about a particular pin code, then you know that at most you have to put in 1,440 trials before you can hack the code. So because the number of trials is very high, you might need to get more information, like probably the first digit of the code. That narrows down the number of shuffles again. The more information you have, the less effort. Now,